All right. So for this lesson, we will be talking about factorials. So before we get too far, let's start by reviewing some grade 11 concepts. So we want to review FOIL, or in other words, our distributive property. So when I have two brackets like this beside each other, it's really important that I use my distributive property to ensure that I don't accidentally miss any multiplication. Now, some people may be familiar with the acronym FOIL, and what this stands for is first, outside, inside, last. I personally like to draw the arrows. It just helps me to ensure I don't miss any, but if you like to use the acronym FOIL, absolutely works. So we just need to make sure that we do all of that multiplication. So x multiplied by x will give us x squared. X multiplied by 4 will give us 4x. Negative 3 multiplied by x will give us negative 3x. And then negative 3 multiplied by 4 will give us negative 12. Then we need to ensure that we collect any like terms. So I have two things here that have x's. So I can collect those. X squared plus x minus 12. And that's my final answer. So that's the first one. We'll do it again just so you can see it done again. But hopefully this is coming back to the front of your brain. So for example, B, again, we want to draw those arrows or use the FOIL acronym. First, outside, inside, last. So that first one, x multiplied by x is x squared. X multiplied by negative 6 is negative 6x. Negative 7 multiplied by x is negative 7x. And negative 7 multiplied by negative 6 is positive 42. Be careful with your negatives here. So those negative rules still matter here, so just be really mindful of those negatives. And then we want to collect these like terms in the middle. X squared minus 13x plus 42 as our final answer. So this is a really important step for us to do moving forward. So I do highly recommend to draw those arrows. People just tend to make less mistakes when they draw the arrows. But that's the first piece, the prerequisite really for this lesson. And then we'll move on to the new stuff. So any questions about this part before we move on to the next bit? Okay. Awesome. Okay, so let's start talking about the new piece. We're going to be talking about what are called factorials. So just as a reminder, a factor is a value that's involved in multiplication. So if I'm looking at the number 6, the numbers that I could multiply to get to 6 could be 1 and 6, 2 and 3. All of those numbers are what we call factors of 6. Also, when we're factoring and we put things into brackets, just like up here, the reason it's called factoring is we're finding the factors of this polynomial here. So that's what the term factor means. Now, when we're talking about a factorial, which is denoted by a little exclamation point, it indicates the multiplication of consecutive natural numbers. This part's important. Only natural numbers, which are the positive integers. So 1, 2, 3, 4, all the way up, just the whole numbers and the positive ones. So how this looks, if I were to write it out as a formula, is that n factorial is equal to n multiplied by n minus 1, multiplied by n minus 2, and I keep going until I get down to 1. It always ends at 1, and that's because it has to remain in my natural numbers, which start at 1, go 2, 3, 4. We can't have 0. We can't have any negatives. So most of our calculators should have a factorial button. It should look like this, n factorial or x factorial. You'll see some that look like that too. Most of them max out around 69 factorial, or some include 70, but that's the neighborhood in which it will max out because 70 factorial is already larger than 1 times 10 to the 100. So depending on your calculator, you probably can't get much higher than that. I would never ask you to write anything higher than that, but that's usually where your calculator will max out. So because of that, we do have to work on how to simplify these things if our calculator is unable to give us all of the values. So I find the easiest way to understand these factorials is through some examples. So that's exactly what we'll do, is we'll go through some examples here. So for each of the following, we want to expand and simplify as a product of factors, and we don't want to use a calculator. So we want to first practice. Oh, yes? Was there a question? No questions? Okay. Okay, awesome. If anyone has any questions, feel free to raise your hand or type in the chat. Absolutely happy to answer them. So for these, we want to expand and simplify. We do not want to use our calculators, okay? So when we write out a factorial, we want to write out 3 factorial. We take 3, and then we multiply it by the 3 minus 1, then we subtract 1 again. All the way until we get to 1. We can't continue anymore because we can only use natural numbers. Then we can multiply this is 6. There we go. Now for 5 factorial, we do the same thing. We take 5, multiply it by 4, so we subtract 1, multiply it by 3, 2, 1. Each time we write out a new number, we're just subtracting 1 each time. Just like that. So we just keep subtracting 1. And then I can multiply this. So 5 times 4 times 3 times 2 times 1 will give us 120. So that's how I write out a factorial, and that's what your calculator is doing when you use that factorial button. It's multiplying all of those numbers that are smaller than our factorial number. Now, sometimes we divide these, and the reason why we're going to practice with dividing these is when we actually use formulas that we'll be working with in the next couple days, we have to divide these. And it's actually quite simple to divide them because a lot of pieces cancel out. So for C, what I'm going to do is I'm going to expand it so some things cancel out here. So I have 7 factorial divided by 4 factorial. So what I'm going to do is I'm just going to expand my numerator and my denominator. So we'll have 7 times 6 times 5 times 4 times 3 times 2 times 1. I just expanded the numerator. And now I'm just going to expand the denominator. So I'll have 4 times 3 times 2 times 1. Now what I want to do is I want to cancel some things. So these cancel, these cancel, these cancel, and these cancel. So I'm left with 7 times 6 times 5. There we go. And then if I were to multiply that, We have 7 times 6, which is 42, multiplied by 5 is 210. There we go. Now, one really important thing to note here is look at the pieces I canceled out. This here is for factorial. This here is for factorial. So because 7 is bigger than 4, 4 factorial lives within 7 factorial. So if I look here, 4 factorial is within that. So I could have also written this 7 times 6 times 5 times 4 factorial instead. And that is exactly what we're going to do with this next example, because sometimes the numbers are just too big to fully expand. Sometimes that's just way too much. So this next one, we have 95 factorial divided by 92 factorial. So I'm going to start by expanding the numerator. So we have 95, 94, 93, 92. Now, if I were to continue expanding, I would write 92, 91, 90, 89, 88, and I would keep going all the way to 1. Now, 92 all the way to 1 could also just be written as 92 factorial instead. And this is very convenient, and the reason why I'm going to stop there is because I have a 92 factorial in the denominator. So I want to stop so that I have the matching number in the denominator. This way I can cancel. Just like that. And this will give me 95 times 94 times 93. And we'll use our calculator to do this multiplication, which is, excuse me, 830,490, just like that. There we go. Now you can see why this is important. Because in my calculator, if I just try to type 95 factorial, I get a math error. That number's too big for my calculator. So is 92 factorial. So in order to work with these numbers, I have to simplify them like this. I have to cancel things, or else I actually can't figure it out with my calculator. Are there any questions at all so far?
Is there an easy way to do multiplication of factorials as well?
Not really. There aren't really any specific rules to it. There's nothing that would cancel things like that. So no special rules for that one. With that being said, though, because you're multiplying such big numbers, it's likely your calculator might max out at a certain point when we're multiplying them. For our purposes, we'll really just be dividing them, and that's really how you use them most of the time. And once we start using the formulas, you'll see why.
Okay, thank you.
Any additional questions at all? Okay. Seems like we're okay. If at any point I'm going too fast, you need me to slow down, go back to a spot, let me know. Okay, so we're going to try something a little bit different now. Similar properties, but we're going to use it in a bit of a different way. So now we want to solve for the value of x. So we're going to do some solving. We're going to use some algebra. And we need to remember that x is a natural number. Again, this means that x is 1, 2, 3, 4, and bigger whole numbers. Can't be 0, can't be a negative number. It doesn't allow for that. So we just need to keep that in mind as we go through. Okay, so we're going to solve for x. And this is where things get a little bit tricky. So I want to go through it nice and slow. So we have x factorial divided by x minus 2 factorial. So what I want to do is I want to simplify this just like I was doing before. Now, in order to cancel these, I want to expand the larger one. Okay? So x factorial would be bigger than x minus 2 factorial. The reason for this is that x is greater than x minus 2. We want to expand the larger one. So that's what I'm going to do. X is bigger than x minus 2, so I will expand x factorial. So to expand x factorial, we have x, then we multiply it by x minus 1, just like we were doing before, right? We subtract 1 each time. Then we multiply that by x minus 2 factorial. And I can write that factorial because if I were to continue, I would have x minus 3, x minus 4, etc. And I would just keep going. The reason I'm stopping there is because I have an x minus 2 in the denominator, and I would like to cancel those. So that's why I'm stopping there. So now I can cancel them. So these x minus 2 factorials cancel. And we're left with x multiplied by x minus 1 equals 20. Now here's the tricky bit. And this is why this was in our prerequisite skills. Right now, we have a quadratic. We need to solve a quadratic. So in order to do that, we're going to follow the steps that we practiced in the prerequisite skills. The first thing that we're required to do is we need to multiply everything out. The reason for that is this isn't equal 0. So I need to move this over here. And in order to simplify things, I need to have this multiplied out. So let's do that. We'll multiply this out using our distributive property. So we have x squared minus x equals 20. Now the first thing we have to do is we have to ensure that this is equal to 0. So we're going to move this over here just so that it's equal to 0. So we'll have x squared minus x minus 20 equals 0. Next, we want to factor this. That's the next step. So we want to factor this. So just like before, we want two numbers that add to the middle number and two numbers that multiply to the last number. Like that. So my numbers will be 4 and negative 5, 4 and negative 5. And we always just take a moment to verify that those work. And then I can put them in the brackets. X plus 4, x minus 5 equals 0. And then I set each of those brackets equal to 0. Now the reason I set each of these brackets equal to 0 is because they're being multiplied. So if the first bracket equals 0, it will zero out the whole thing. If the second bracket equals 0, it will zero out the whole thing. So we'll have x plus 4 equals 0 and x minus 5 equals 0. So now what I'm going to do is I'm just going to isolate for x. So we'll move that 4 over, x equals negative 4. Move that 5 over, x equals 5. Now our final answer had to be a natural number, which means a positive whole number. So 1, 2, 3, 4, extending that way. So that means this one is rejected. We don't use that one because it is not a natural number. So that one is therefore rejected. And this is our final answer. Now, just like any time you're solving an equation, you can actually put it back into the equation and verify your answer. So that's always really nice with these is I could, even in my calculator, put in 5 factorial divided by 5 minus 3 factorial oops, 5 minus 2 factorial, my bad, sorry. 5 factorial divided by 5 minus 2 factorial, and I end up getting 20. So you can verify it in your calculator as well, just to make sure you got everything right. Are there any questions before we move on to example B? We're going to do all 4 of these. So if anything was a little unclear, we will do more, but if you have questions in the meantime, please ask. Any questions? Okay. Let's try another one. Always helps to do lots of these because they are a little bit confusing. So for B, we have x minus 1 factorial divided by x minus 2 factorial. So the first thing that we want to do is we want to expand the larger one. So x minus 1 would be bigger than x minus 2. If you find that hard to understand which one's bigger, you could always try subbing in a value for x and seeing which one's bigger or smaller. So we always want to expand the larger one, which is x minus 1. So let's expand that. X minus 1, x minus, remember we subtract 1 again, and we have x minus 2. So I'm just going to put the factorial there so that we can cancel some things. There we go. So now we can cancel out the x minus 2 factorial. And we're left with x minus 1 equals 25. Now, because we only have one x, like a single x on the left-hand side, it's not a quadratic. We don't have to worry about factoring. We don't need to worry about any of that stuff. We can just solve normally. So we want to isolate for x. So this negative 1's got to go. When it goes over the equal sign, we add that 1, and we'll get 26. Now you don't need to show every single step here. I just want to make sure it's really clear for everybody and that they don't miss anything. Any questions about that one before we move on to the next two? Okay. All right, let's try another one together. Let's try another quadratic one that's a little tougher. So we'll go down here. So for example C, we have n minus 1 factorial divided by n minus 3 factorial equals 30. So the first thing we want to do is we want to identify which one's larger, the numerator or the denominator. So the numerator we've subtracted 1, the denominator we've subtracted 3. So the numerator is definitely larger. So we're going to expand the numerator. N minus 1, n minus 2, n minus 3 factorial. And we divide this by n minus 3. Now the reason I knew to stop at n minus 3 was just so that it cancels out with the denominator here. Then I'm just going to cancel those. Still equal to 30. And I'm left with n minus 1, n minus 2 equals 30. So this time around, I have a quadratic again. The reason I know this is a quadratic is I have two n's being multiplied, so that would give me an n squared. Because of that, I need to multiply this out because it needs to be equal to 0. So let's multiply this out. So we'll have n squared minus 2n minus n plus 2. And in order to solve a quadratic, it must be equal to 0. So we have to move this 30 over to the other side. So we'll have n squared minus 3n plus 2 minus 30. N squared minus 3n minus 28 equals 0. There we go. Next thing we want to do now is we want to factor. So we need to factor this. So we want to find two numbers that add to the middle number and two numbers that multiply to the last number. So those numbers will be -7 and 4, -7 and 4. So I can put those into the brackets. N minus 7, n plus 4 equals 0. Then I can set the brackets equal to 0. So hopefully solving quadratics is coming back for people. So we have n minus 7 equals 0, n plus 4 equals 0. And now I isolate for n. N equals 7, n equals -4. Now, just like last time, we can only have values that are natural numbers, which means positive whole numbers. Therefore, this one is rejected because -4 is not a positive whole number. So that means our answer is n equals 7. Any questions about that one before we go to the next one?
I have a question.
Sure.
What would you do if you have two natural numbers?
Then you would have two answers.
Okay.
Yep, you could absolutely have two answers that work. So you would just say my answers are 7 and 4 if it was like positive 4. That's a great question. Anything else? Okay, let's try example D together. Then we'll do a proof and then we can do a couple extra ones to solidify this. So the next one, we have n factorial all over 3n minus 1 factorial. So we're just going to kind of ignore the 3 for right now. Let's not really think too much about it because our goal is to cancel out this factorial. That's our goal, right? If you notice all the other ones, we canceled out the factorial. So that is our goal here. So to do that, we're just going to look at n and n minus 1 and determine which one is larger because we always expand the larger one. So n will be bigger than n minus 1, so we'll expand that. So we'll have n minus 1 factorial all over 3n minus 1 factorial, and that is still equal to 4. Now what we want to do is we want to cancel our n minus 1s, so that's great. And now we have n divided by 3 is equal to 4. So now we just want to isolate n. So n is currently being divided by 3 on the left-hand side. So to move it, we have to do the opposite operation. So I multiply by 3 on that side, and then I'll multiply by 3 on this side. So it will give us n equals 12. And if I subbed that back into the original equation, we would end up getting the same answer. Any questions about this part before we move on to the proof, and then we can do a few other examples? We're good. Oh, great question that was just asked. So for factoring, do you need to show all the middle steps or can you just jump to the factored form? You can absolutely just jump to the factored form. I just want to make sure everybody knows exactly where everything is coming from. But you can jump right to the factored form. And that's as hard as our factoring gets. Next question, where did we get the n minus 1 from? So for the numerator, what I've done here is I've expanded the factorial. When we expand factorials, each time we just subtract 1. So when I'm working with n factorial, to expand that, I just do n, and then I subtract 1, then I subtract 1 again, and then I subtract 1 again, etc. I'm going to stop here and just write n minus 1 factorial, which would account for all of this stuff. That way I can cancel it out. That's the goal. We want to cancel out these factorials. That way we can solve it. But that's where that came from. Okay. So we're going to do a proof. And if people haven't, not everybody's done a lot of proofs before. And I'll explain kind of what a proof is. So in math, sometimes we want to prove things mathematically. We want to show that, in this case, 0 factorial is equal to 1, and it is always equal to 1, and here is why. If you try on your calculator, a 0 factorial, I get 1. But sometimes we want to know, why is that? Why do I get 1 all the time? Will I always get 1, or are there cases in which this isn't true? So that's why we do proofs. We want to show that this is always this way, no matter what. So I'm going to walk you through how to do this. I will not ask you to do a proof on an assessment. However, if anybody is thinking about going into higher level mathematics, understanding how to do proofs is very, very important. So what we want to show is that 0 factorial is equal to 1. So let's just kind of write out a few pieces that we know about factorials just to get some usable equations and some things that we could sub in. So this one has a bit of a trick to it, but since n plus 1 factorial, we're going to look at that, is equal to n plus 1 times n plus 1 minus 1 factorial. And this is the same thing that we were doing because all I did was I subtracted 1, right? Now this is the same thing as n plus 1 multiplied by n factorial, right? Hopefully that part makes some sense, right? N plus 1 factorial is n plus 1 multiplied by n factorial. So what I'm going to do is I'm going to rearrange this. The goal is to get n factorial by itself so that I can try my best to rearrange this and then sub in 0. That's my goal. So now what we're going to do is we're going to rearrange. So I'm going to write next if we rearrange. And when we're doing proofs, we often want to explain what we're doing as we're going through. So since I have this, I can now rearrange. So we have what we would have if I rearrange. I'm just going to divide by that n plus 1. So I'll have n plus 1 factorial divided by n plus 1 equals n factorial. So all I did is I moved this over here. Right? So I divide by n plus 1 here. And I divide by n plus 1 here. That's what we did. Here we go. So now that I have this equation, we're going to try subbing in n equals 0. So this will help us to show what 0 factorial is if I sub in 0 for n. So we'll sub in n equals 0. So we'll have 0 plus 1 factorial all over 0 plus 1 equals 0 factorial. So let's simplify the pieces on the left-hand side. That will give me 1 factorial over 1 equals 0 factorial, which gives me 1 equals 0 factorial. So that's where it comes from. That's an example of a mathematical proof. Again, not something we will do on our assessments, but important pieces to see how these things are put together, especially if you are going into higher level math courses, if that's something that is a goal of yours.